Hello everyone and welcome to .NET Core Central. In today's video, I'm going to talk about authentication for MCP server. How we can authenticate an MCP server, making sure that it is not open to everyone and provide access to only people who have authenticated access. So for that, what I'm doing is I'm using an API key based authentication mechanism. Now, if you want to know a little bit more about API key based authentication mechanism, Google has a very good article on why and when to use API key. I would suggest you read that. But at a high level, API key identifies calling project, an application or site making call to an API. So essentially, if you are having application to application communication, that's a good usage of API key based authentication because API keys identify application, whereas if you're using authentication token, they identify user. That's the fundamental difference between the two. And I also wanted to highlight some security concerns with API key. API keys are generally not considered secured because if they are stolen, it's very hard to identify and then prevent. Of course, you can disable the API key and provide a new API key to the clients or users. But one of the strategy what a lot of people uses is expiring API key at a certain interval. It can be 3 months, it can be 6 months, or it can be a year. The shorter the expiration range, the better it is. Now, having said that, let's get into the MCP server that I created a last video, which exposes a weather-based tool. Now, what I have done is for this particular MCP server, I created a standard ASP.NET Core middleware. In this middleware, all I'm doing is I'm checking the header containing authorization. And if the header contains authorization, I extract that value as API key. And then I check if this API key is valid. So right now the API key valid is looking for a hard-coded API key, which I'm using for testing. But essentially this is where we are going to go against the API key storage and validate. In most cases, API keys might be encrypted and saved in a database or use something like Key Vault, Azure Key Vault, or AWS Secret Manager. And this is where you will validate and ensure that the API key is a valid one. And from API key, you can identify the client's identity. It's essentially an client ID or account ID, which can be retrieved because in a multi-tenant system, you would probably need to know which client is trying to access the data based on their API key. So this all will happen here, but I'm not covering these because these are standard development practices that we use today. It has nothing specific for an MCP server. But the fact that we can add a standard HTTP middleware in an MCP server, which can be responsible for extracting API key from header and then verify it. And here, just like adding middleware in a standard ASP.NET application, we can add the middleware using the use middleware and provide the middleware in the pipeline. So, and I have done it before map MCP after the builder.build. So once you do that, now your HTTP middleware is in the pipeline. So I'm going to run this application. Now you can see that the MCP server here is up and running. Now let's go into the client code and see how we can pass this particular key from there. Now what I have done is I put a breakpoint in the middleware so that we can see when the server gets a call back to the middleware. If we go back to the chat agent that we created last time, which is a semantic kernel code which uses the MCP server. If you have not seen my last video, I would encourage you to go back and see it. And I'll share the links of all the videos that are necessary to understand till this point. So in the semantic kernel implementation, in my last video, we had up till the endpoint. Now what we can do is after the endpoint, we can add this new attribute called additional header, which is a dictionary of string and string. And here we are passing the authorization as the header key and the API key as the header value. And then this transport is used creating the MCP client. This MCP client is then used to extract tools, and then these tools are added as a function to the plugin. And then the semantic kernel ultimately uses this MCP client to execute the call back to the server. Now, as you can see, this also means that for the application to application communication, you can have one API key per client transport because the additional header is added as part of the client transport itself, which means you will have to either have the account as a property, and based on certain condition you can use the account ID as a part of the MCP call, or you can create one client transport per account or per client ID and then use them that way. This is the two different options. So let's start with the simple one API key way of doing. Rest of the code remains same. I did not change anything. So let me run here. And once we run, at the beginning itself, we are going to get a callback. Even when we extract the tool information, and as you can see, even when we are extracting the tool information, the call is going to server to authorize. And here we can see that the API key is part of the authorization header. So we can run through, and now we see that it extracted the tool, and then we can ask a question. What is the weather of New York? And if we run it, now it came back and it is trying to have the API key, and I'll put a breakpoint here to show you that the API key call is going to first happen. It figures out the API key from header, validates it, then it goes and tries to execute the tool, which ensures that only authenticated user can go and execute the tool. So as you can see, this worked as expected. Now what we can do is we can add something called account ID here, and then we can print out the account ID. So now we added an extra parameter to the weather, which is the account ID. I'm showing you the second mechanism where we don't have to create one client transport per account in a multi-tenant system. So here the idea is this particular chat agent, which is again, this chat agent is a server-side component. It is going to run in your server. So technically, this particular chat agent can be an API, which can be exposed via auth-based authentication or some sort of JWT token-based authentication, where you can extract the client ID when a call comes in. And then that client ID can be passed to the assistant. So now if we have to simulate that, what we can do is to the assistant call itself, we can pass the account ID and see the AI understands that this is the account ID and sends it back to the get weather call. Okay, so this gets, I'll also update the description here, gets the current weather of a specified city and account ID, just to give a little bit of extra context to the AI. So the server is up and running. Next, I'm going to go and start the agent code here. And like before, the agent code is going to trigger the call to the server a couple of times. And now I'll say provide weather of New York for account ID 12345. Let's see. So now it is going to go. First thing it did is authorization. Next is came here, and we can see here that the AI is able to understand the account ID, picked it up and send it to the get weather. So we got the city and account ID, and then here you can do account ID based logic par method. Now, one thing to keep in mind, this ensures when you implement this way of passing account information between server and client, you will have to make sure that your server, your MCP server, can be used only within your application, because passing the account ID is kind of the responsibility of the client. And if your MCP server is a public one, then you cannot rely on the client to pass account ID. But on the other hand, if the MCP server is a real public MCP server, then this is not even needed, because then you are anyway expecting each client to use their MCP client to make a call to MCP server, which means they will have their independent API key. This problem that we can pass only one header is only when your application is internally, when you are trying to identify between multiple accounts or multiple client IDs. This problem does not exist if your MCP server is a public MCP server and it's been called by your client themselves. Then you don't have to worry about it, because they will have their individual client transport par MCP client, and they will pass the API key for their own API key. So this is not even a problem in this scenario. This is a problem when only when you are managing the MCP client and you are trying to figure out which client is responsible for the call. And in that case, here though, I am making the user pass the account ID in a chat window, but that's not going to be the real life solution. In real life, it will be an HTTP API where you can extract the client ID and then you can pass it to the AI when you make an MCP call. Basically, in your prompt, you can pass the account ID. In the prompt itself, you can say, for this account ID, get me weather for the city which is coming from the API request. That's how you can do. And I'm going to do a video of semantic kernel with web API, and in that I'm going to explore that a little bit more. So that is all I wanted to cover for today's video. If you like this video, please give it a thumbs up. And if you are new to this channel and you think you are getting value out of this channel, please subscribe to the channel. And thanks so much for watching this video.